We have another problem out of the section on u substitution, indefinite integrals. We have the indefinite integral of 4y dy over the square root of 2y squared plus 1. Let me select the crayon there. We're just going to go by the I was trying to think. Now I have a y here. I'm just going to go by the rule of thumb to let u equal what's under the radical in the denominator. Just remember, we're looking usually where, let u be the composition, and it's usually what's in the denominator under the radical. There's all kinds of little rules of thumb, but it's really what we're looking for to set u to is if something we can set u to, that when we take the derivative of it, that derivative is present somewhere else in the denominator, in the integral expression. And if you notice, if I take the derivative of 2y squared plus 1 and I differentiate both sides of u equals 2y squared plus 1, I get du equals 4y dy, and notice I have a 4y dy in the numerator over here, so I can say that that's equal to du, and therefore I would have the square root of u in the denominator in place of 2y squared plus 1, and that makes this much easier to integrate. In fact, almost before it was been impossible. So now I have 1 over the square root of u du, since du equals 4y dy, and I have that right here. I'm just going to change this to the integral of u to the negative 1/2 du, and then I'm going to integrate, so I'll go up by the power of 1, so negative 1/2 plus 1 is positive 1/2. Put it over the new power, and then plus c, bring that fraction out of the denominator, multiply by its reciprocal, you get 2 times the square root of u, and remember u is 2y squared plus 1. And then don't forget your plus c, and that is that's it. And actually, you could actually do this a different way. You could actually set u to the entire denominator here and get the same thing. But this is probably the way you would think to do it, so that's the way I'm going to do it. But yeah, if you set it, then you would get du is equal to 4y over the square root of, you would almost get it. I think this is a little more straightforward, probably the way that you would, as a beginning calculus student, intro would probably see this best. But you could set it to the entire denominator and manipulate it and get it from there. But anyway, this is good enough, and this is the answer, so there.